Today, I'm going to be building a band of musical agents using the framework Eve. Now, some time ago, we built a sequencer in Svelte where you place the notes by clicking them in, playing them back, and changing the tempo as you go. So that worked pretty well, but now I want to take it a little bit further. Instead of me clicking in all of the steps myself, I'd like to just give a little prompt and have an agent fill in the notes for me. Or actually multiple agents, one for each instrument. So I'll have different instruments. I'll have a drummer, a bassist, and a keyboardist. And the drummer will have a kick, a hat, and snare. And we'll have a producer agent put it all together and see what it sounds like. So this is the app that we're going to build, going from prompt to different agents, writing parts for the different instruments and placing them on the grid. And we'll be using Eve from Vercel as the agentic framework to orchestrate it all. Right, so if I sketch out the solution, I'm thinking I'll just have the UI as it is today, with Tone.js being responsible for all the audio playback. Then on the agentic side, I'll use Eve as the framework. I'll set up an agent called producer. And this producer will take in a prompt that I write. Let's say the prompt can be something like, play a lo-fi 80s beat with a melancholic melody in A minor, for example. What that'll do is the producer will take that prompt and create something called a brief. And that'll use a tool to do that. That brief will then set a tempo, and it will send the tempo back to the UI, so the tempo will change. Then it will send all of that information to the drummer. The drummer agent will then create a beat, and that beat will then be returned to the producer and then be passed to two agents at the same time, and those agents will be our bass and the keys. And why we're doing it this way is that if I imagine I'm in a band, if the whole band just plays at once, there's a risk that they could clash. So what we want to do is have one instrument start and have the others observe and then come in. So here we have a bit of a workflow, and we have agents that are going to be responsible for writing their own parts. The way I'm thinking about it at the moment is I'll have the drummer over here, and when the drum parts are ready, they'll be popped into the grid and they'll start playing. We'll have then the grid for keys and bass, and they'll be pending until they are ready. Once the bass is ready, it will get popped onto the grid. Once the keys are ready, they'll be popped onto the grid, and then we'll have the full track orchestrated playing together. Now let's get into what that would look like in code. If we look at the documentation, Eve describes itself as a file system first framework for durable AI agents. And those are two concepts that Eve does a little differently in comparison to other agentic frameworks. And this is how the file system first looks like. An agent is a folder containing an agent.ts file that specifies the model and the runtime. The system prompt is in an instructions.md file. And then similarly, tools are just files that are popped inside of the tools folder. Any tool that you add into that folder will be auto-discovered by the Eve framework. Sub-agents are simply folders. And at first glance, if you're familiar with Next.js, it's not that dissimilar to how Next.js handles routing through folders. In the code, agent.ts defines the model and the reasoning effort. A tool is a function that the model can call with a fixed input shape. In this case, the producer agent has one jam tool, which we'll call the set brief. And that will handle storing the key, the tempo, the swing, and the sound bank. The instrument sub-agents don't really use tools. They run in something called task mode, which means that they return a single structured part as their answer. Okay, so that takes care of the file system first part. Now, the second idea is about sessions. So within a session or a conversation with an agent, each message that you send is a turn, and each turn breaks into steps. For example, calling a model or running a tool, and steps emit events as they go. So the basic idea here is that if a process dies in the middle of a turn, or you come back later for a follow-up, Eve will allow you to continue where you last left off. Those sessions are also files, and we'll get into them later. But for now, just remember sessions, turns, steps, and events. The models themselves can be found in Vercel's AI Gateway, and there's a whole list of providers from text, image, video. You get one API key that'll cover the whole list, so changing the model is simply changing a line in the agent.ts file. Okay, so I'll start up the server, I'll build and start, and then it should load Eve running on port 2000. Now this version is a little bit buggy. The hot reload isn't really working for me, so I'm starting and building. And then with bun run dev on the front end, we'll run the UI. And there we have the app, it's running. Before any agents are running, we have a handwritten, hand-coded arrangement on the grid right now. So this doesn't require any agents, no API key. It has the same shape and the same schema as the agents will be requiring. And we can just take a listen and see what that sounds like. Nice. Yes, I could get into that. Okay, cool. So you can see then there are no agents running. It's all just on the player on the front end. Now, I'll leave the vibe as it is and I'll hit jam. The browser opens an Eve session over HTTP and it starts streaming events. You can see it's reading those events. And now it's dispatching the drummer. And the first thing that happens is that the BPM changes. The agent is calling other tools. It's dispatching the keys. So now we're going to see the bass and the keys come in. Okay, it's a bit of a different vibe, right? Nice. Okay, so what happened here, right? Well, the first thing that happens is that the tempo changes. The producer calls the set brief tool, which is the one tool it has. And it's turned this lo-fi, F minor, dusty drums, sparse bass into an actual number. It's got a BPM. Then it's got a key, a mode, a swing, and a sound bank. So it's looking for like which sound bank we're actually going to draw from. The browser then applies that to the transport straight away without waiting for any notes to be written yet. The fixture just keeps looping at the new speed. So given that there's some latency between the producer handing off to sub-agents and them coming back, I decided to just keep that player head running so that we can still feel like something is still happening. Okay, so let's take a quick look at these sub-agents. So I have the bassist, I have the drummer and the keys. So the first thing that happens is the producer reaches out to the agent. It doesn't really actually have any tools. We have defined the agent to use Claude Sonnet 5 for now. And the instructions basically are telling the drummer that it is a drummer and a couple of things that it should do. It is also being told that it gets access to a kit, that it should only use these sample paths to choose the parts of the kit that it wants to return. Then it's got an output shape here. It replies that it is providing the drums part and it will show which voices it should return. And I'll show you, for example, here in the public folder, I've got some samples and here I have the lo-fi parts here. The hat, the kick, percussion, snare, and I have the files here. That's where it's drawing its sound samples from. It makes those decisions, it builds up the drum part, and it returns into a fixed shape that the producer is expecting back. Now if we look at the keys, we see something very similar. So we have the agent definition, and the instructions tell it that it is a keys player and it should return one keys part as per the structured output. Here's the structured output and we see that it's going to return a series of notes together with a duration and velocity. Now the velocity is important because without the velocity, the notes will all play at the highest volume. And we want the keys agent to decide at what velocity it wants to return its part. And then lastly, when we look at the bassist, also a very similar thing. Here we have the instructions with the structured output. And one thing to also note that I didn't mention with the others is that keys and base need to return steps, because LLMs are not really good at doing sort of beat time arithmetic. So they're going to just reply with what notes should be played on that step, how long those notes should actually sustain for, and then at what velocity that note should play. If there were multiple notes, it would be a chord, but this is a bass, so no chords on the bass, please. If we look at the terminal, this is what the producer decided to send to all the players. The producer decided the BPM, the key, what mode, and that all comes from the prompt when we said lo-fi in F minor. So a very simple template that the agents pick up and run with. Okay, so now let's return here and see it in action again. I'm gonna paste in a new vibe. I want melodic keys with a house beat and a funky vibe. Then I'm going to refine this. I'll keep playing so we can keep hearing the sound, and then I'll refine it and let's see what happens. Streaming status, refining band. You see the BPMs changed. Right, dispatching the drummer. So the snare, hat, and kick are thinking. And the bass and the keys are cued. Ooh, okay, so now we have the kick, snare, hat closed, hat open, percussion playing, while the bass and the keys are thinking. So they happen in parallel, the sub-agents, but they continue playing. Nice. Bass and keys have loaded in. Now we have the full band playing together. Our status is band is ready at 124 BPM. F Dorian. We got a nice little jam here. Now I'm gonna write something in here. Let's do a bit of reggae, chilled vibe, a happy melody in C major. Let's refine this. Now the producer is gonna process what the band should do next. Ooh, and we already got the BPM changing. We're waiting for the drums to change. Drummer is thinking. Drummer has loaded its new files. And now we have the bass and the keys queued. Now they're thinking. The vibe is still the same until the bass and keys come in. Ooh. Now they have. Yeah, now I can even play along if I want, like. Yay! Playing here with you. Yeah, producer, you know what to do. Sweet. Alright, let's continue. Okay, so that's quite simple, right? Now, I want to look at the durable AI agents part in Eve's claim and how that actually works. Back in the code, if we go back into the root and we go into the .eve folder, there is a folder called workflow data. And here we can see events, hooks, runs, steps, streams directories. Inside of these directories, if we go into steps, for example, we can actually see that the steps are logged as files. And this is, again, where Eve uses the file system first approach to persist state. Now, we haven't talked a lot about Tone.js or how that works. And if you're interested in, please watch the other video where I'm using Tone.js and Svelte to create the original sequencer. But one of the nice things about Tone.js is that if I go back to Eve and I kill the agents, so we have Eve is not running anymore, I go back to the browser, I can press play, and the music still plays. Because the music is all handled by Tone.js on the front end. So that was my basic band of agents turning the old Svelte sequencer into something a little bit more dynamic. If you've made it this far, thank you so much for following along. But most important of all, try it yourself. Post some comments below and tell me what you think of Eve. And more importantly, tell me what you're building. Until then, I'll see you in the next one.